First, which of the following statements are true? Number A. If a number is divisible by 3, it must be divisible by 9. Well, it is false. The reason is 6 is divisible by 3, but 6 is not divisible by 9. So A is false. B. If a number is divisible by 9, it must be divisible by 3. It is true. The reason being, factors of 9 are 1, 3 and 9, and 3 falls in the factors. Here you can see. Therefore, any number which is divisible by 9 will also be divisible by 3. So it is true. C. A number is divisible by 18 if it is divisible by both 3 and 6. It is false. Reason is, we can take 60 which is divisible by 3 and 6, but it is not divisible by 18. So this is false. D. If a number is divisible by 9 and 10 both, then it must be divisible by 90. It is true. Reason being, 9 and 10 being co-prime. So their product 90 will divide any other number. And co-prime is a number which has common factor as 1. E part, if two numbers are co-primes at least, it is saying at least one of them must be a prime. Well, it is false. 9 and 10 are composite numbers, but together they are co-primes. So it is false. All numbers which are divisible by 4 must also be divisible by 8. It is saying all. So it is false. 20 is a number which is divisible by 4, but it is not divisible by 8. All numbers which are divisible by 8 must also be divisible by 4. It is true. Factors of 8 are again 1, 2, 4 and 8, and 4 falls in the factors. Therefore, number will also be divisible by 4 if it's divisible by 8. Therefore, it is true. H. If a number exactly divides two numbers separately, it is saying separately. Let's take that 3 divides 6 and 9 separately. So it must exactly divide their sum. Well, yes, it is true. 6 plus 9 is 15 and it is divided by 3. Therefore, H is true. If a number exactly divides the sum of two numbers, it must exactly divide the two numbers separately. We have taken 2 and 4, whose sum is 6, which is divided by 3. But 3 doesn't divide 2 and 4, so I is false. That was your question first. Second, here are two different factor trees for 60. Write the missing numbers. So this is an easy one. We have two factor trees for 60. So here 60 can be written as 6 into 10 and 6 can be written as 2 into 3. Therefore we have written 3, and 10 can be written as 5 into 2. And here in another tree 60 is 30 into 2. Therefore we write 2. 30 is a product of 10 into 3. Therefore we write 3, and 10 can be written as a multiple of 5 into 2. So that was your question second. Third, which factors are not included in the prime factorization of a composite number? Well, 6 is a composite number and the factors of 6 are 1, 2, 3 and 6. We are taking an example. So prime factors of 6 are 2 and 3. 2 and 3. We are talking about prime factors, not the factors itself. So therefore we don't include 1 and the number itself in the prime factorization. And the number here is 6, so we don't include it in prime factors. So this is your question third. We don't include it. Fourth, write the greatest 4-digit number and express it in terms of prime factors. So greatest is obviously 9999, and when we prime factorize it, first 3 into 3333, then 1111, then it is divided by 11 by 101 times, and here we represent it. Now the factor tree is 9999 can be written as a product of 9 into 1111. Similarly, 9 can be written as a product of 3 into 3, and 1111 can be written as 11 into 101. Fifth, write the smallest 5-digit number and express it in the form of its prime factors. So 10,000 is the smallest 5-digit number. It can be written as 2 4 times and 5 4 times. So here the factor tree would be 4 into 2500 gives 10,000, 2 into 2 gives 4, 25 into 100 gives 2500, 5 5s are 25, 25 is 100, 4 5s are 20, and 2 2s are 4. So you can see that the root node nodes here contains 4 2s and 4 5s. 5s are here 1 2 3 4. So 4 5s. This is how you do question 5. Sixth, find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime factors. So here we have prime factorize it, that is 7, 13 and 19. It is simple prime factorization. 13 goes 19 times to give you 247, 19 goes 1 times to give you 19. And ascending order is the similar 7, 13 and 19. Here we observe that if we subtract 13 minus 7 and 19 minus 13, we get 6 as the common difference. So this was your sixth question. 7. The product of three consecutive numbers is always divisible by 6. Verify this statement with the help of some examples. So we have to give some examples to prove it. So we have given it. Number first is 1 into 2 into 3. These are consecutive numbers, and it will be divisible by 6. Its product will be divisible by 6. Similarly, for 2, 3, 4, 24 is divisible by 6. And here 3, 4, 5. And for 3, 4, 5, when we multiply it, it gives 60, and which is divisible by 6. And then for 4, and then for 9, 10, and 11, it gives you 990, which is again divisible by 6. So this was your question 7. 8. Sum of two consecutive odd numbers is divisible by 4. Verify this statement with the help of some examples. A is 1 plus 3. These are consecutive odd numbers. It gives 4, which is divisible by 4. 3 plus 5 gives you 8, which is divisible by 4. And 11 and 13 are again two consecutive odd numbers, giving you 24 as a sum divisible by 4. Last one, 15 plus 17 gives you 32, which are again two consecutive odd numbers, which is divisible by 4. Their sum is divisible by 4. So these were some examples. So this was your question 8th. 9th, in which of the following expressions prime factorization has been done? So it is very simple. Look, 4 could be written here as 2 into 2. So it is not prime factorized. So it is false. For the B part, all the prime factors are there. So prime factorization has been done in this case. Here again, all the prime factors are there. Therefore, it is again true. Here 9 could be written as 3 into 3. Here 9 is a composite number, so no prime factorization has been done. So this was your question 9th. 10th, determine if 25,110 is divisible by 45. 5 and 9 are co-primes. Test the divisibility of number by 5 and 9. So we will use the hint. Since last digit is 0, therefore this number is divisible by 5. And to check with the 9, we have to add it, and the digit sum is 9. 2 plus 5 plus 1 gives you 9. Therefore, this number is divisible by 9. So, number is divisible by 45 as well. Since 5 and 9 are co-prime, also 5 and 9 are factors of 45. So this is how we do question number 10. 11. 18 is divisible by both 2 and 3. It is also divisible by the product, that is 6. Similarly, a number is divisible by both 4 and 6. Can we say that the number must be divisible by its product 24? If not, give an example to justify your answer. Well, the big answer is no. It's not always true. Why? Because we can take an example. 12 and 36 are both divisible by 4 and 6 separately, but they are not divisible by 24. So it is not always true. It may happen for some cases, but it is not always true. So it is false. This was your question 11th. 12th. I'm the smallest number having 4 different prime factors. Can you find me? Well, it is very simple but tricky. Look, 4 different small prime factors are consecutive prime factors are 2, 3, 5 and 7. So when we multiply 2, 3, 5 and 7, we get 210. So it is the smallest number having 4 different prime factors. That was your question 12.